Welcome, Ichak Solution. This is Loci, complex numbers. So in this question, we are given that describe the locus represented by imaginary of 1 over z plus 2 is equals to 1 over 4. Alright, so the first thing here, we are going to express this equation in the form of x and y. So what we know that z is a complex number which can be written as x plus yi. So we are going to take this part here of 1 over z plus 2 equals to, then in place of z we are putting x plus yi here plus 2. So the next thing now, we can group the real part together. This is x plus 2, which is the real part, plus yi. Alright, so next thing now, we need to multiply the numerator and the denominator by the conjugate of the denominator here. So you can see we have x plus 2 plus y. So the conjugate here, this plus on the real part, on the imaginary part, will becomes a minus here. So it will be x plus 2 minus yi. That's the term that we are going to multiply on the numerator and the denominator here. Alright, so let's see here by conjugating. So we are going to multiply with x plus 2 minus yi on the numerator, then x plus 2 minus yi on the denominator. So now you can see on the denominator we have a complex and its conjugate. So multiplying a complex and its conjugate is just real part squared plus imaginary part squared. Then on the numerator here, you can see we have x plus 2 minus yi here. Alright, so now we can split the real part together here and the imaginary part here. So you can see the real part is x plus 2 all over the denominator minus yi all over the denominator here. So that's our denominator. So our term or our complex in splitted form, the real part is this one, and this is the imaginary part. Alright, so now we go to the next step here. So the next step, they are saying the imaginary part is equals to 1 over 4. So our imaginary part, you can see it's the one that is being multiplied with I. So that's the imaginary part here. So it's minus y over x plus 2 squared plus y squared is equals to 1 over 4. Alright, so now we need to simplify this equation. So you can cross multiply here such that we can simplify. So we are going to have x plus 2 squared plus y squared is equals to minus 4y. Alright, so now we can take this 4 to the other side. So we are going to have x plus 2 squared plus y squared plus 4y is equals to 0. So you can see here x plus 2 squared is in completed square form, so which is okay here, it's a perfect square. But on this part here, y squared plus 4y here, you can also complete the square here. Alright, so we have x plus 2 squared plus y plus 2 squared minus 2 squared by completing square. So now you can now see we have x plus 2 squared plus y plus 2 squared is equals to 4. So now you can see this is the equation of the circle with the center of minus 2 here and the radius of square root of 4 here. So the locus represent a circle with a center minus 2 and the radius of root 4, which is equals to 2 here. So that's the locus that is being represented by imaginary of 1 over z plus 2 is equals to 1 over 4. Right, so let's go to the next example here. So the next example here is saying describe the locus represented by real of z plus 2 over z minus 2 is equals to 0 here. Alright, so we know that z is a complex number, so it can be written as x plus yi. So we are going to replace in place of z with x plus yi. So let's take this expression here. So we are going to have z plus 2 over z minus 2 is equals to x plus yi plus 2 all over x plus yi minus 2 here. So now we can group the real parts together and the imaginary part together. So we are going to have x plus 2 plus yi all over x minus 2 plus yi. So now we can conjugate by multiplying the denominator and the numerator by the conjugate of the denominator. So the conjugate of the denominator, you just go on the imaginary part here. If there is a plus, it becomes a minus. If it's a minus, it becomes a plus. So we are going to multiply with x minus 2 minus yi on the denominator and also on the numerator here. So remember, on the denominator here, this is a complex and its conjugate. So if you multiply a complex and its conjugate, you just take the real part and you square it, plus the imaginary part, you also square it. Alright, so let's go to the next part here. So we are going to have x plus 2, x plus open brackets 2 plus yi close brackets, then x minus 2 plus yi close brackets, all over the real part squared plus the imaginary part squared here. Right, so if you look closely here on the numerator here, you can see that we have the a difference of 2 squares here, because it's x plus this term, then x minus this term. So this is a difference of 2 squares, which is going to give us x squared minus 2 plus y I close bracket squared, all over x minus 2 squared plus y squared. So now we can simplify this part, which is 2 plus y squared here. So by simplifying, we are going to have x squared minus open brackets 4 plus 4yi minus y squared, all over x minus 2 squared plus y squared. So now we can multiply with this negative inside of this bracket. So we are going to have x squared minus 4 minus 4yi plus y squared, all over x minus 2 squared plus y squared. So now we are interested in the real part. So real part of this expression, you can see is x squared minus 4 plus y squared, all over this one. That's the real part. And the imaginary part is minus 4y minus 4y I over x minus 2 squared plus y squared here. Right, so the next thing now, we are taking the real part and equate to 0. So our real part here is x squared minus 4y plus y squared, all over x minus 2 squared plus y squared is equals to 0. So now we can cross multiply with the denominator here, and we are going to be left with x squared minus 4 plus y squared is equals to 0. So automatically here you can see this becomes x minus 0 close bracket squared plus y minus 0 squared is equals to 4. So you can see clearly this is the equation of a circle with the center at the origin and the radius of root 4, which is equals to 2 here. So this is the locus being represented by this by this equation, real of z plus 2 over z minus 2 is equals to 0 here. Thank you for watching the video. See you in the next lessons.